Limiting and excess reagents. I get what you're thinking. When are we going to use anything we've learned in chemistry in real life? To be honest, I'll agree with you that most of it is useless to us. However, I chose this topic of limiting and excess reagents because it is the most real-world relatable topic in Chem 20. It's actually important. Knowing the limiting and excess reagent in any situation is immensely beneficial. You do this all the time without thinking about it. Let me explain what I mean. Every recipe with more than one ingredient has a certain and important ratio of ingredients that must be followed. The problem is, most stores don't sell just 780 milliliters of lima bean juice, or only half a cup of milk, or any specific amount the recipe would call for. My point is that when you or your parents buy ingredients for a specific meal, they do calculations to ensure they buy enough food. Another quick example. Let's say the recipe calls for 7 potatoes, but potatoes are sold in groups of 6 at Safeway. You need to buy 12 potatoes in order for you to have enough potatoes. You now have an excess of 5 potatoes. Potatoes are one of the excess reagents if the recipe is thought of as a formula. Recognize a question like this? What mass of water is produced when 5 grams of hydrogen chloride react with excess magnesium oxide? The word excess is important. It is there because in order to find the correct answer, we need to know which reactant is the limiting reactant. Essentially, the limiting reagent or reactant is the one that will run out first. Instead of excess, the question may also say sufficient. They mean the same thing. If it doesn't tell us anything about the amount of magnesium oxide and it happens to run out in the middle of the reaction, we're assuming it's an excess, our equation doesn't account for that. For this reason, limiting and excess reagents are vital to chemistry as well as the real world. This topic is mainly about determining the actual amount of precipitate or solution created from the combining of 2 reactants. That's wrong, don't read the solutions, where the question doesn't state that something is in excess. Now, let's do some chemistry. This is an example from page 299, number 1. You can follow along if you want. What would be the limiting reactant if 4 grams of chromium and 6 grams of iron nitrate were used in the reaction below? So here's our equation. Essentially, what you do for most questions is find the moles of product that will be produced by each reactant. So you do it twice. Reactants on the left if you don't know what I'm talking about. And then whichever reactant makes the less moles of product or mass, you can go an extra step if you want. I do, but it doesn't matter. Assuming the other reactant is in excess, is the limiting reactant. So whichever one produces less is the limiting one. It'll run out first. So here's our equation. We know the mass. We know the molar mass. So the limiting reactant will be the substance that produces less precipitate. This is the precipitate because it's a solid. You can also calculate it for this. Doesn't really matter. So if we assume excess iron nitrate, like we do in many questions before this unit, then chromium, 4 grams, we'll find the number of moles, the mole ratio. You can stop here and compare the moles, or you can go the extra step to find the grams. I do. That will give you 4.3 grams of iron. Now, if we assume excess chromium, we will have our 6 grams of iron, and we're going to find the moles, mole ratio, cancel out moles for grams, and we get 1.86 grams of iron. So this is the limiting reagent because it will only produce this much. It will run out after producing that much iron, and this won't even happen. That's a false number in this scenario. So if the question asks you how much iron would be created, the answer is essentially 1.86 grams of iron. We already calculated that in doing the question. The answer is 1.86 grams. Another example, same page, number 3. Predict the mass of zinc sulfide produced from the reaction of 15 grams of zinc with 15 grams of yellow sulfur. So this is important in our equation because this is in a group of 8 because this sulfur naturally occurs in groups of 8. And then we're going to balance the equation. 8 there, 8 there. Now it is balanced. So here's our balanced equation. This is what we know about it from the question and from our periodic table. We know the molar masses. So we're going to do the same thing. If zinc is in excess, we're going to have 15 grams of sulfur divided by the molar mass times our mole ratio. Cancel out moles for grams. That would give us 45.59 grams of zinc sulfur if zinc was in excess. If sulfur was in excess, we'd have our 15 grams get moles, mole ratio, cancel out moles for grams, we would produce only 22.35 grams of zinc sulfur. So, let's see. Sulfur is the excess reagent in this equation, and 22.35 grams is the amount of zinc sulfur that will be produced from this combination reaction. So here's another real-world example. Joey's making hot dogs. He likes 2 packs of mustard, 1 pack of ketchup, 1 pack of relish, 1 hot dog, 1 bun, and 1/8 of an onion per hot dog. So this is what Joey has for ingredients, and we're wondering what the limiting reagent is and how many hot dogs Joey can make. So here's our information, and the ratios are in the question. I know them. It'll be hard for you to follow, but just trust me. There are multiple ways to find the answer, but I'll show you the best way to do it and how I'm going to do it. So I'm going to see how many hot dogs I can make with each of these values alone. And then whichever amount is the least, I know that that is the limiting reagent. So here's how many hot dogs we can make. Ketchup can make 60, mustard can make 45 hot dogs, onions can make 120, etc. So mustard, that's the lowest one. Therefore, mustard is the limiting reagent, and Joey can only make 45 hot dogs before he has no more mustard. 45 hot dogs, mustard. That's the answer. That's how you do it. Real world. This is everything you need to know to complete this topic. Obviously, you will see this skill again if you continue chemistry as well in everyday life. See ya. Good luck on your test, by the way.